In this video, we'll be talking about key features of quadratic functions and how to graph a quadratic function by using those key features. So example that we're going to do is y equals negative 2x squared plus 4x plus 6. And we're going to algebraically determine its key features. So first we got to talk about what the key features of a quadratic function are. So one key feature for any function is its intercepts, both x and y intercepts. For quadratic functions specifically, we need to find the vertex and the axis of symmetry, because we know a quadratic function is going to make a parabola, which is symmetrical. All right, so let's try it. I always start with the y-intercept first because it's the easiest. So to find a y-intercept for any function, you just plug in x equals 0. So let's do that for this function. Y equals negative 2 times 0 plus 4 times 0 plus 6 is just 6. So all those zeros are going to go away. So the y-intercept isn't 6, it's the point 0, 6. We plug in x equals 0, find a y, and so that's a point. So let's plot this point on our graph. And, while we're here, label a scale a little bit. I'll do that on the other axis too. You don't have to label every block, but just make it clear that we mean that one block is 1 unit for us. All right, let's do the same for the x-intercept. I say the same, but it's not really the same at all. We're going to plug in y equals 0, and that'll give us 0 equals negative 2x squared plus 4x plus 6. And because there's both an x squared and x, we need to use the quadratic formula. The square root property won't work to solve for x, so go into quadratic formula. X equals, now if it helps, label your a, b, and c. So a is negative 2, b is 4, c is 6. Negative b would be negative 4, or opposite sign of b, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So as we discussed in class, for the part under the square root is where we're starting. It's actually called the discriminant. We're just going to type it in. 16 minus 4 times 2 negative times 6 equals, it would help if it was on, you get 64, but let's actually do it. 2 negative times 6 equals. All right, 64. So this is negative 4 plus or minus the square root of 64 all over negative 4. This is great because the square root of 64 is just 8. So that means our x-intercepts are at negative 4 plus or minus 8 over negative 4. But there are almost always, I shouldn't say almost always, usually 2 x-intercepts for a parabola. And we need to make sure we're seeing this as 2 different answers. Negative 4 plus 8 would be 4 over negative 4, which is negative 1. Negative 4 minus 8 is negative 12 over negative 4, which is positive 3. So our x-intercepts are the points negative 1, 0 and 3, 0. I'm going to go ahead and plot those right now so I don't forget. Negative 1, 0 and 3, 0. And so now we have 3 points. We can already see like, oh, well, the vertex is going to be up here, right? And make a upside down parabola. But we really should find the vertex because we need to know how far up it goes. Does it go up here? Is it here? Is it just barely going above that y-intercept? So let's find the axis of symmetry. To do that, we're going to use the formula x equals negative b over 2a. And it's the same a, b, and c from the quadratic formula. So it's -4 over 2 times -2, which is -4 over -4, which would be +1. So our axis of symmetry is the vertical line x equals 1. So it's not the number 1, it's the line x equals 1. Great. So that's half of the vertex. The other half is plugging in that x value to find what y is. So to find the vertex, y equals, in the original formula, we're just going to plug in x equals 1. So -2 times 1 squared plus 4 times 1 squared plus 6 equals -2 plus 4 plus 6, which is 8. So the vertex is the point 1, 8. And that's another point that we can plot, 1, 8. And using the axis of symmetry, we can get another point over here. And, 5 points is pretty good to get a good shape, but we might want to know, like, well, how far down does this go, right? Is it really steep? Does it go wider? So another thing you can do is just plug in extra points. I never want us to sort of have to wonder. It's easy to plug in an extra point. So I'm just going to plug in x equals 4, so that way I know how far down this goes. Right? We don't have anything drawn down here. We want a point. But I would just plug it into the original formula. -2 times 4 squared plus 4 times 4 plus 6. And we just type that in the calculator to clear the other one. 2 negative times 4 squared plus 4 times 4 plus 6 equals, and I get -10. So that gives us another point, and with the axis of symmetry, it actually gets us 2 other points. So that gives us a pretty good idea of what this parabola looks like. So don't be afraid to just plug in numbers and get some extra points. But key features are you need to have the intercepts and the vertex clearly on your graph. Let's try another one, because this was a lot, right? That we're putting together a lot of things we've been learning. So let's try another one and make sure this all works out. So this one has a fraction. We can handle it though. It says y equals 1/2 x squared plus 4x, and we're going to sketch a graph by algebraically determining its key features. I want to mention something because, throughout class, I've been big on, you see a fraction, get rid of it. That only works if you're solving for x. It doesn't work so well when there's 2 different variables. So I can't just multiply both sides by 2 because then I'd have 2y. We want y equals and then the function. So getting rid of the fraction is not going to work for us in this one. But let's start with what's easy, the y-intercept. The y-intercept, we plug in x equals 0. So y equals 0 plus 0, which is 0. So our y-intercept is also our x-intercept, or at least one of the x-intercepts, and it is 0, 0. Because both x equals 0 and y equals 0. Okay, that's an important point. Let's find the x-intercepts. We know one of them is going to be 0, but there's usually 2. So any x-intercept is when y equals 0. So in this case, it'd be 0 equals 1/2 x squared plus 4x. Because there's both an x squared and an x to the first power, we need to use the quadratic formula. If this were just 1/2 x squared plus 4, then I could get x squared by itself and square root both sides. But 2 x's means quadratic formula. Sometimes people get thrown off when there's only 3 terms on a quadratic function. We can always just add a 0 there. So our c is going to be 0, the constant term. Our b is going to be 4, and our a is 1/2. Don't let the fractions freak you out. It's just a half, right? We can handle a half. And if it's really bugging you, call it 0.5. But I think we can do it with the fraction. So let's try it. X equals negative b, negative 4, plus or minus the square root of 4 squared minus 4 times a times c all over 2a. And in this case, it actually works out pretty well to have the 1/2 because these are just going to cancel, so we don't have a fraction anymore. And in this case, multiplying by 0 makes this one go away. So what I'm ending up with is negative 4 plus or minus the square root of 16. And then I'm just dividing by 1. So it'll be negative 4 plus 4 or negative 4 minus 4. Because dividing by 1 isn't going to do anything, and the square root of 16 is 4. So that's 0 and negative 8. So that makes the x-intercepts, the points, remember we want to think of them as points. The x-intercepts are the points 0, 0, and 8, 0, or negative 8, 0. So let's plot those points. I already got 0, 0 because it was also a y-intercept. Let's go back here to negative 8. Maybe label some axes while we're over here. Negative 4, negative 2. 2, 4, 6, 8, just to get some scale established. All right, we did the hard part. We got through the quadratic formula. Now it's time for axis of symmetry. So let's use the formula. Axis of symmetry is always x equals negative b over 2a. It's a vertical line, and it's the same a and b from the quadratic formula. So that'd be negative 4 over 2 times 1/2. Negative 4 over 1, which is just negative 4. So our axis of symmetry is the line x equals negative 4. It's a vertical line, not a number. And looking at this, I probably could have figured that out without this formula. Do you see how it's halfway between the two x-intercepts? That will always be the case because that's what an axis of symmetry is. It's what divides the whole parabola in half. Now that we have it, to find the vertex, we need to plug in to the original formula. Y equals 1/2 negative 4 squared plus 4 times negative 4. And again, use a calculator, right? Don't be afraid to use a calculator. At this point in the course, that's totally fine. If you're worried about the 1/2, type it in as 0.5. 0.5 times 4 negative squared plus 4 times 4 negative equals negative 8. So that means the vertex is the point, again, these are points, negative 4, negative 8. So we can plot a point at that location. Negative 4, I better go down to negative 8. Now, so that's 3 points, right? And we can make a U shape, right? It's sort of clear what this will look like. But it's also easy enough to plug in a couple extra points if you want to know, like, well, how far over does this go? So maybe for an extra point, I'll just plug in x equals 1 and see, like, where I should put the next point. So extra point, let's just plug in x equals 1 into the original formula. Y equals 1/2 times 1 squared plus 4 times 1, which is just going to be 4.5 or 4.5. So 1, 4.5, we can use the axis of symmetry to get another point over here. And then that's starting to look a little bit more clear what this is going to be like. But if in doubt, you can always get more points too.